This is the luckiest maths teacher in the world. Thank you so much for tuning into this video. Today we're going to look at the distributive law, what it is, and how we might use it in mental multiplication calculations. So we've already gone through the associative and the commutative laws. So now we're going to look at a different law, the distributive law. It involves two operations. It involves multiplication and addition. It also involves brackets. So when we have a multiplication outside the brackets, something like this, the distributive law says we distribute the thing outside the brackets to everything inside. So 2 outside of 4 times 3 is the same as 2 times 4 plus 2 times 3, okay? So we know, we can easily check this. So 4 plus 3 is 7. So I've got 2 times 7 here. So 2 times 4 is 8. 2 times 3 is 6. Now I have 14 equals 14. 2 times 7 does equal 8 plus 6. So thank God it works. So if you have a minus in between the two numbers, you just change the minus there. So if it was 2 times 4 minus 3, you distribute the 2 to the 4. You distribute the 2 to the 3, and you have a minus in between them this time. So 4 minus 3, is 1, times 2 is 2, 2 times 4 is 8, 2 times 3 is 6, 2 equals 8 minus 6. We're right in both cases, okay? So that's what the distributive law is. So when you start with brackets and you end up with something that doesn't have brackets, we call that expanding. So what we've done here, starting with brackets, ending up with no brackets, is called expanding, not to be confused with how we wrote numbers in expanded form in place value. How might we use this to perform a multiplication calculation without a calculator? Well, let's say I have something like 39 times 11. Now, you've probably been using this method without realizing it. So timesing by 11 isn't that easy, but timesing a whole number by 10 is really easy. You just stick a 0 at the end of it. So what I do is I rewrite that 11 as 10 plus 1. So I go 39 times 10, 39 times 1, and put a plus between them. This is really easy to do because 39 times 10 is just 390. 39 times 1 is 39. Adding those two isn't too difficult. I get 429. So that's a quick way that you can multiply by 11. But there are other numbers you can do too. We're going to look at an example using the distributive law to multiply by 9. So I'm going to get rid of this example in blue. Please pause and copy down if you need it. So let's say I want to perform the calculation 9 times 27, right? So of course, it doesn't matter the order I multiply because multiplication is commutative. So I can write that as 27 times 9. So now, instead of writing it as 10 plus 1, I'm going to write it as 10 minus 1. So using the distributive law, that's just 27 times 10, this time minus 27 times 1. So 27 times 10 is easy. You just add a 0 at the end of it. Subtract 27 times 1 is easy too. And you just get 243. How easy is that? So we're using the distributive law to do these calculations much, much easier. So it doesn't just involve 10 and 9 and 11, there are other examples too. Again, I'm going to get rid of this example in blue. Please pause and copy down if you need it. So let's say now I'm going to do the example 21 times 17. Okay, so that's not easy to do off the top of your head. So what we want to do is we want to write one of these numbers in an easier way to multiply. So none of them is really close to 10, but 21's close to 20. Multiplying by 20 isn't hard. You multiply it by 10 and then double it. So what I can do is I can write this as 17 times 21 because the order of multiplication doesn't matter. So I write it as 17 times 20 plus 1. So I go 17 times 20 plus 17 times 1. So 17 times 10, just add a 0 to it, you get 170, double it, 340. So it's 340 plus 17. Well, how easy is that? That's 357. I think we did, using the distributive law, a much, much quicker job than we could have done if we were using other methods. So once again, I'm going to get rid of this example. Please pause and copy down if you need it. So we can use other examples too. Let's say 28 times 15. So none of these numbers are close to 10. Isn't that easy? But what we can do instead is we can write this 15 as 10 plus 5, because multiplying by 10 is easy, multiplying by 5 is easy. So 28 times 10, we just add a 0 at the end. Now 28 times 5, we can figure out 28 times 10 and halve it. So 28 times 10 is 280. So 28 times 5 is just half that. So 280 plus 140, you can probably do that much, much quicker now. 420. How easy is that? So that's how the distributive law can help us with mental multiplication. So there are other methods we can use to help us with mental multiplication, such as when we multiply by 4, we double the number and double it again, and we'll look at those in the lesson. But for now, just make sure you understand the distributive law and how we can use it to help us in multiplication. Thank you so much for watching. This has been the luckiest maths teacher in the world. Have a great day.